Assalamu alaikum. Bismillahirrahmanirrahim. We're doing Juniper certification, and that was specialist level JNCIS, and the category is service provider routing and switching specialist JNCIS-SP. Okay, we're discussing MPLS. Last day we discussed RSVP, the traffic engineering database. Today we discuss the module 8 RSVP LSP bandwidth reservation. Okay, so when you create the LSP, you need to define the LSP bandwidth. Okay, so need to reserve the bandwidth. So today we discuss how to reserve and how to verify the LSP bandwidth or reservation bandwidth. Okay, so same topology. Let's go and start our slide. Today's slide RSVP LSP bandwidth reservation. Okay, let's start. This is a very small topics. There is two section basically. First section we'll discuss the benefits of RSVP bandwidth reservation, and second section we will configure LSP bandwidth reservation. RSVP LSP bandwidth reservation. Okay, let's start. First, discuss the benefits of RSVP bandwidth reservation. And this is some terminology and acronyms which is already discussed in last couple of classes. So let's start. So what kind of traffic goes over an LSP? This part one. So see the figure. And there is two line. One is red line, another is blue line. Okay. And this customer is CE router, and this is the B router, and this is the internet. Okay. So some traffic is forward towards router 1 to router 5, and blue line traffic forwards router 6 to router 10. That is basically this topology. Okay, they're considering here internet service provider ISP, and the edge router is router 5 and router 10. Both router is connected with the internet service provider. Some traffic is travel. The path is the red line is router 1 to router 5, and the blue line, that is blue line is router 1 to router 10. Okay, that's the one example. So let's go to our slide. Okay, then the requirement is what types of traffic go over an LSP in a service provider network. Using a policy, you can map specific traffic to a specific LSP. Okay, I can map. How to map? Using the path. We already discussed in last time. When we define the path, we can mention two mode. One mode is loose mode, and another mode is straight mode. When we define the LSP path. Okay. So if you do create a policy, a new question arises like, will certain LSP host more important traffic? Maybe you can consider some customer is uh, very good customer, and some customer is normal, and some are bad customer. Okay. So you can separate your traffic based on customer prefix. Okay, so this is your parameter when you massing traffic or when you massing the customer. You can define different LSP for different customers. Okay. How much traffic goes over an LSP? How much traffic? See here, the physical interface is, if you consider the physical interface is 1G, that means the maximum traffic capacity is 1G. If you use 10G link, the maximum throughput will be 10 Gbps theoretically, but it will go maximum 9 plus, not 10. Okay, LSP have different bandwidth requirements. You you can push traffic router 1 to server. This traffic requirement can vary, depends on requirement. And blue line, maybe their volume of traffic will be big compared with red. Okay, so you need different traffic volume for different LSP. Not all are equal. Okay, so LSP to the internet may carry a huge bandwidth. LSP to management platforms may be lightweight. Okay, so how much traffic goes over an LSP? LSP have different bandwidth requirements. Okay, already I have talked with this. An LSP that backhauls traffic from a central office to a PE. This is central office and this is PE router. This basically describe the requirement as an example. Okay, so see here, RSP LSP bandwidth reservation. RSVP LSP can reserve bandwidth along their path. Along their path. See here, the main physical interface is 1 Gbps links, 1 Gbps links, and 600 Mbps reserved. So you have 400 Mbps available. Very simple math. Very simple math calculation. Total will be 1000. If you reserve 600, left will be 400. Okay. Prevents too many high bandwidth LSP from taking the same path. See here, router 1 to router 5. Router 1 to router 5. This is the red line or orange line. The router 1 to router 5 LSP comes up first because see here, the reservation bandwidth is 600. My interface total bandwidth is 1 Gbps. So there is no problem. If we if we want to reserve more than 1 Gbps, in that case, your LSP will not comes up. Okay. Its link on the path now has 400 Mbps left available. So you need to calculate your physical interface bandwidth and your LSP reservation bandwidth. Okay. Many potential equal cost paths. Like you can consider 6, then 1, then 2, 3, 4, 5. Multiple path. You can create multiple LSP here. Okay. And it's completely depends on customer requirement, delivering good service towards the customer. Okay. This is the available or possible path. Therefore, router 6 to router 5 does not even consider those links. LSP definitely takes the bottom path. Bandwidth is nicely distributed. The chance of packet loss is reduced. So, you create multiple LSP to utilize both links. Underutilized links and overutilized, both are balancing, traffic balancing. Okay. So, in that case, you can say we're using optimum when you create MPLS LSP. So need to reserve LSP bandwidth properly. Okay. So how to when you define the reservation bandwidth, you can define the priority, LSP priority. Okay. If you configure one LSP priority is higher than other, their traffic will be considered as uh, considered as platinum, or you can say gold. Okay, just for comparison. Okay. Uh, RSP priorities. So RSVP bandwidth reservation is not a policy. It's a it's not a policy, just binding the bandwidth. It's not a policy. Just you have available 10 Gbps interface traffic or interface capacity. You can reserve for 500 Mbps for one customer for one LSP. Okay, that's the calculation. But this is not the actual policy, not the bandwidth limiter. Okay. So RSVP bandwidth reservation have no impact on the actual data. It is not a policy that limits and drops traffic. It will not drop traffic, not limit the traffic. Okay. Reservation are purely in the control plan, just controlling the LSP, controlling the LSP. Only used while LSP are calculating a path. Once the LSP is up, it can send as much traffic as it likes. Okay. Think of the RSVP bandwidth reservation as a suggestion to the rest of the network. So we just understand what is the RSVP bandwidth reservation. It's not a limiter, bandwidth limiter, or it's not a bandwidth policy. It will not drop and traffic. Okay, it's just for handling control plan or MPLS control plan. Okay, the accuracy of manual bandwidth reservation. This is the one graphs LSP bandwidth, that is GBPS 0 to 10, and this is basically timer, and this is the direction router 1 to router 5. This is nothing else very important. Now we're in Q&A section. Check your understanding. What is the main purpose of bandwidth information when you configure a bandwidth reservation on an LSP? To calculate the path that other LSP take. Okay. What is the role of traffic engineering extensions to advertise bandwidth reservation? Traffic engineering extension basically advertise the bandwidth reservation information from ingress router to egress router. What are the characteristics of the RSVP bandwidth reservation? RSVP bandwidth reservation take different paths from the very start. The reservation are purely in the control plan, just managing the traffic in multiple link or different links. Okay. So now we are moving to configuration section. How to configure the RSVP LSP bandwidth reservation. So let's start. So our topology is same. See here, one example, router 1 to router 5. We're just assigning level switch path, router 1 to router 5, and the reservation bandwidth is here 400 Mbps. 400 Mbps. And this is the total command. Total command set protocol MPLS level switch path name. This is the destination or egress router. And last one is a reservation bandwidth. And when you reserve bandwidth, you can use K for kilobit, M for megabit, G for gigabit. So there is 400 Mbps. 400 M means 400 Mbps. How to verify this? Show MPLS LSP name, the LSP name detail, and you can see the reservation bandwidth here. Okay. So let's verify our command for our topology here. So router 1, edit protocol, MPLS. Under MPLS protocol, see here, one LSP is available here. The LSP name is BMX1 to BMX5. This is the destination 1.5. 1.5 is my egress router, and this is the path. This is the path information. Okay. So now need to configure LSP reservation. Okay. BMX1 to BMX5. and you can help. You can take help the bandwidth. The bandwidth to reserve. Before bandwidth reservation, you can check current status. Run show RSVP interface. Okay, run show RSVP interface. See here, two interface is enabled for RSVP. So the available bandwidth is 1 Gbps or 1000 Mbps. No reservation is here. No reservation is here. 0 BPS, 0 BPS. So total available bandwidth, and this is the ZE interface. Total bandwidth is 1000 Mbps and available bandwidth also 1000 Mbps. No reservation has taken here. Okay. So now we want to set level switch path BMX1 to BMX5, then bandwidth reservation. So see here the bandwidth, say the command level switch path name, then bandwidth. Okay, so bandwidth, and you can assign the bandwidth value. So similarly, are taking 400 Mbps. So say here 400 Mbps configured. Now we check the reservation status. So say here the interface Z 0 by 1 static bandwidth is 1000 Mbps. Available bandwidth is now 600 Mbps and reserve bandwidth amount is 400 Mbps. Okay. So reservation already taken. Reservation already taken. Okay. And this is the one verification command. And another verification command will be LSP. If you press the command run show MPLS LSP, and the LSP name, your LSP name is BMX 1 to BMX 5 and detail or extensive. See here the bandwidth 400 Mbps. The bandwidth reservation is 400 Mbps, and also we are getting the same information from RSVP interface. Reservation is 400 Mbps and the available bandwidth is 600 Mbps. So consider here the interface Z 0 by 0 that is BMX1 to BMX2. This interface bandwidth is not reserved. It's not reserved. Reserved bandwidth from the interface is Z 0 by 1. Why? Because this LSP goes to BMX1 to BMX6. See here the record route path, you can understand. First hop is 10166. 10166, that is BMX1 to BMX6. Second hop is 10677. 10677. That means your LSP path is this path. That's why you get here this interface reservation. Okay, that means LSP RSVP LSP reservation, it depends on LSP path. LSP path. Okay. So check from router 6. From router 1, we are just configure bandwidth reservation in router 1. Okay. Now check from router 6. Run show RSVP interface. See here, the reservation happened automatically. Reservation happened automatically. We will not configure LSP or reservation in VMX6 edit protocol, that is dynamic. Okay. See here, this is different LSP. We're not configuring this LSP, this LSP. We're not configuring this LSP. This destination is 1.5 and this destination is 1.10. That is different LSP. But they are making the reservation based on record route path. Okay, based on record route path. So that is fantastic. This is automatically happened. Okay, that's good. Okay. RSVP bandwidth reservation interface verification. Show RSVP interface. Already I I showed this verification command already. Show RSVP interface. Show TED database extensive R3. You can check from TED database. You can check from TED database also. Show TED database from router 1. Go to router 1 and show TED database. That is total database here. Okay, there is total database 1.1, that is 1.2, 1.3, 1.4, 1.5, 1.6. So if you take it in detail, then you can get the bandwidth information. Okay. The bandwidth information is where so TD database extensive. Sorry, the command will be extensive, not detail. Extensive. See here the 1.1, that is 1.1 node, and see the bandwidth calculation, static bandwidth, and others interface bandwidth information, maximum LSP, and we'll go 1.6, 1.3, 1.4. That is multiple. This is extensive R3. That means 1.3. 1.3. 1.3. 1.8. That is 1.3. And this is the bandwidth total information, maximum LSP bandwidth priority, and others information. Okay. So this is another verification. Here we can see the priority, available bandwidth priority BPBS, reservable bandwidth. So after extensive, we can see here 192.168.1.6. Yes, getting this. Say here 1.6, 1.6 node. So we're getting the available bandwidth information. 600 Mbps now available, 400 Mbps already reserved. Okay, you can check or verify with this command also. Okay, let's go for next slide. Set protocol MPLS labels this path. This is the LSP name to this one bandwidth. Another bandwidth reservation that is 700 Mbps. And this is the path is router 1 to router 4. That is router 1 to router 4. Previous one was router 1 to 5. Router 1 to 5. Check and double check. Okay. Previous one, router 1 to router 5, the reservation bandwidth was 400. Now we're making another LSP that is router 1 to router 4 and the bandwidth is 700 Mbps. So our physical interface capacity is total 1000 Mbps and two LSP taking more than 1000 Mbps. Okay, what happened now? Routing around bandwidth constants, your LSP from router 1 to router 5 reserves 400 Mbps of bandwidth. Now configure an LSP from router 1 to router 4 that reserves 700 Mbps bandwidth. The metrically based path is from router 1, router 2, router 3, router 4, router 1, router 2, router 3, router 4. But these links only have 600 Mbps available. You can't make this one. You can't make this LSP with 700 Mbps, okay? Because you have left only 600 Mbps. The 1 Gbps links do not have enough bandwidth to accommodate the LSP from router 1 to router 4. So the LSP will take blue path in this diagram. So in that case, say here, they are just sharing you. I'm making 400 Mbps reservation. They are taking this path. Okay. So if again we are making another LSP that is requirement 700 Mbps, that is not possible. If I'm making router 1 to router 4, this LSP path will be this one. Okay, not this one. Okay, that is the consideration. So you have to maintain this one. That's good. Pruning unsuitable links from the topology. Basically, it's happened constant shortest path first. We're discussing constant shortest path in later chapter or later slides. We're not discussing CSP today. 700 Mbps. This is the same verification command, basically. Oversubscribing and undersubscribing RSVP. By default, an interface of RSVP is full bandwidth. Okay, you may want to change this. Undersubscribing the interface. What if 20% of your traffic is pure IP? Reduce the available RSVP bandwidth to 80%. Our subscribing is the opposite. Okay, so consider here, if you oversubscribe your bandwidth at a ratio of 3 to 1, then you could have 30 customers is with 10 Gbps circuits, all sharing 100 Gbps service provider backbone. Okay, so it's you can just consider, say here, this is the ZE interface, that is gigabit Ethernet interface, but my subscription, after subscription, we're taking 400. After sub bandwidth, we're taking double. This is called the oversubscription. This is called the oversubscription. Okay. Use subscription for percentage. Interface interface name increased by 500%. Use bandwidth for direct numbers. That is 2 Gbps. 500, that means 5 Gbps. 5 Gbps and 2 GB is it's directly defined. Actual bandwidth is this, but your subscription is this. You can configure our subscription. So actually no need, basically no need to configure our subscription. And this is the monitoring real-time data analysis command, monitor level switch path, then level switch path name. Okay, you can check real-time traffic for any LSP, real-time traffic of any LSP. So now we're just, I think, ending of the slide. Now we're in Q&A section. Which command? Question one is, which command is used to see the traffic rates over a particular LSP? Monitor level switch path. Okay. What action is taken if 20% of the traffic is pure IP in the full 10 Mbps RSVP LSP interface? Next. Basically, reducing the available RSVP bandwidth to 80%. Okay. 20%, that means 100 minus 20 is equal to 80%. What does the symbol S indicate in the given example? This is the command of one LSP. And here is S means strict hops. S means strict hops. When you see here L, that is loose hops. So that's all for today. Our topics just go to today's topic summary. Our today's topic was LSP bandwidth reservation, and the bandwidth reservation. It's not a rate limiting or policy. It's we are using this for controlling the traffic. We are using this the controlling the traffic or balancing the path. Okay, okay. So and this is the consideration of RSVP bandwidth reservation, and we are checking how to configure this one. Very simple. Just go to your specific LSP and set the amount of reservation bandwidth. Reservation bandwidth. Okay. Then they will just you create or configure a reservation bandwidth in ingress router. No need to configure in every backbone router. Okay, it's dynamically traversed from ingress router to egress router. That is the magic, or that is the, you can say, dynamic feature of a MPLS RSVP LSP. So I think that's all for today. Is there any question, Justice? No question. Okay, Allah Hafiz. So now stop record.